Thank you again for coming out for our last xTalk for this fall semester. My name is Jovi Nazarino. I'm part of the residential education team in Open Learning. My role in the team is I'm a learning science education outreach specialist, and one of the awesome things that I get to do is welcome guest speakers like we have today. Today's xTalk is on creating assessments that engage students and improve learning. So we have three amazing guest speakers today. We have Laura Frawley, Jonathan Bloom, Andreas Karatsolis. Laura is a senior lecturer in brain and cognitive sciences. She will be sharing about her use of concept maps. John is a senior lecturer in mathematics and the experimental study group, and he'll be talking about MITx, Pset checkers, and his use of active learning in the classroom. And we have Andreas, who is a senior lecturer and also the director of writing, rhetoric, and professional communication in CMSW. And he will be talking about peer and instructor feedback on oral communication. So altogether, we have presenters here who have all implemented approaches to ensure that their students are growing their skill set in areas desired from the course using various forms of assessment and feedback. So all that being said, the way we'll have them present is we'll have Laura present first, we'll have John present second, Andreas third, and then we'll open up for discussion with all of you. So I just ask if we can just let everyone present and hold your questions until that time. So all that being said, Laura, when you are ready, I will let you go and take over the share screen and get started.
Thanks for the introduction, Jovi. As she mentioned, my name is Laura Frawley, and I'm a senior lecturer in Course 9, Brain and Cognitive Sciences. I'm really excited to share with you today how we use concept maps as a summative assessment tool in 900 and 901 to make student learning more visible. Here's where we're headed today. I'll start with the goals of 900 and 901 and why concept maps made sense for these courses. Then I'll walk us through how we implemented them as part of the assessment structure. We'll look at how students receive feedback on their concept maps, discuss the outcomes, and then leave it with lessons learned and a few practical recommendations. Even before 2020, students were telling us that recall-based assessments weren't helping them actually understand the material. Then when everything abruptly shifted online, high-stakes exams became even harder to give and felt less aligned with what we really wanted students to learn. That combination pushed us to rethink course structure and move toward more frequent, lower stakes assessments that capture conceptual understanding. And that's where concept maps came in. What are concept maps? Concept maps are a way for students to show how ideas connect. Each map starts with a topic or a central idea, and it serves as an anchor. Students place terms related to it around it. Those become the nodes. And these connections, those are linking phrases with directionality. The linking phrases turn those lines into statements about how those terms relate. So students aren't just listing ideas, they're showing the relationship between them. There's also a spectrum of structure. At one end, you have open form maps with low directedness, where students choose the layout and the terms. At the other end, you have highly structured maps, or high directedness, where the instructor provides most of the structure. In 900 and 901, our course goals focus on helping students build a strong conceptual foundation, interpret and evaluate data, connect ideas across topics, and apply what we've learned or what they've learned to future work. Concept maps support these goals directly. They require students to organize and relate terms in meaningful ways, synthesize ideas across topics, identify gaps or misunderstanding in their knowledge. They also make learning visible, both for students who can see how their ideas fit together and for instructors who can use the maps to provide targeted feedback and guide improvement. We start each semester by scaffolding the skill. Concept maps are introduced in recitation. TAs model how to build a map. They walk through an example concept map, and then they construct a map together with the class so students understand the process before they see it in the summative assessments. In 901, we introduced concept maps in fall 2022. They now appear on all of the quizzes and the final assessment. In 900, we introduced concept maps in the spring 2023, and they appear on all 6 quizzes. In both courses, concept maps assessments are open notes, take home, and untimed, which fits the type of synthesis we're asking students to show. Our implementation uses mid-level directedness. We provide the topic, a set of terms, and detailed instructions and rubric. The students decide the layout and connect the terms using arrows and linking phrases. Over the 7 semesters, we've refined the instructions and the grading criteria based on TA and student feedback, so the assessments and grading are clearer and more consistent. A big part of making concept maps work is a clear and effective feedback sequence. For each quiz, students submit their maps in Canvas. TAs grade them and leave annotated feedback in SpeedGrader. And then in recitation, we go over an exemplar student concept map from that quiz. The TA walks through what the student did really well and highlights what kind of issues students overall struggled with. To help students improve, we provide structured and transparent feedback. The rubric is organized into 4 categories: concept mapping skills, content accuracy and organization, interconnectedness, and presentation. Most categories have additional subskills that you can see here on the right. TAs use these same categories when they leave comments, which keeps feedback aligned with the rubric. Here you can see an example of corrective feedback from one of our TAs under minor mistake. And she writes, "The thalamus, rather than Brodmann's area 3B, is the brain's first stop for processing touch." So in cases like this, the TA not only flags the error, but also provides the corrective information so the students understands what went wrong and how to fix it next time. The goal is for the feedback to be consistent, transparent, and actionable. We also scaffold the grading across early quizzes, so students aren't expected to do everything right away. On quiz 1, we're pretty lenient. We mainly want students to get the basic structure and start using linking phrases, even if they're very simple. By quiz 2, although not shown here, we start expecting more meaningful linking phrases that describe the relationship between terms. And then again in quiz 3, we raise the expectations and start asking for interconnections and grading them. Interconnections are links that involve 3 or more terms forming loops rather than simple linear chains. And you can see the progression here from one student on quizzes 1, 3, and 7. And so quiz 1 shows a pretty simple structure, basic arrows, it's fairly linear. Quiz 3 shows stronger linking phrases, that we'll look at in just a moment. And you start to see linking the interconnections here. And then quiz 7 shows much richer interconnection and ties more terms together. So if we zoom in and look closely at an example linking phrase from each quiz, we can see the first quiz, nervous system, has 2 subdivisions, PNS and CNS. And then quiz 3, we get an increase in complexity of the linking phrase. Embryo begins as a flat disc of 3 layers. The layer that forms the nervous system and skin is the ectoderm. And then we remain having really solid linking phrases in quiz 7. Theta rhythms are slower than alpha rhythms, present when a person is awake but relaxed, and they categorize the light sleep stage called stage 1 non-REM sleep. Jovi, Aaron, and I coded all of the TA comments from concept maps for each student from all quizzes across the academic year 22 to 23 and 23 to 24. Here we're looking at the data from 901 from fall 2023. And when we break down the feedback into 3 main types of comments, concept mapping skills in blue, content accuracy in purple, and interconnectedness in orange, we start to see a pretty clear pattern. At the beginning of this semester, a large percentage of students need corrective feedback, especially around basic concept mapping skills and content-related skills. But as the semester goes on, those comments steadily drop. We also see a smaller but steady decline in the interconnectedness-related comments. If we look at the sub-skills for the concept mapping skills, I want you to focus in on the purple bars. Those are the feedback about poor linking phrase quality. In the first 3 quizzes, you can see by far it's the most common type of correction. As the semester progresses, those linking phrase errors drop off sharply. That pattern lines up directly with the scaffolding we built into the early quizzes, where expectations for linking phrases gradually increased. Taken together, the feedback patterns across the last 2 slides show that scaffolding is working. Students produce clearer, more connected maps as the semester goes on. Now let's take a look at how students themselves experience the concept maps. These two charts show 2 of the 4 ranking questions we asked students both in the middle of the semester and at the end of the semester using Google Forms. Both focus on the core things concept maps were meant to support: seeing the big picture and processing information. Across both measures, you'll see that students already rated concept maps as helpful by the middle of the semester. And even more encouraging is that for the most part, agreement increased by the end of the semester. So what we saw on the instructional side, fewer errors and stronger maps, is mirrored on the student side through higher perceived usefulness. In this table, I want to highlight how we implemented concept maps in 2 different introductory courses, 901 and 900. Both use concept maps to support conceptual synthesis, but the logistical context and audiences are different. 901 is a Course 9 and Course 6-9 major requirement. It has about 100 students each semester, 4 TAs. The grading load is substantial but manageable, and the course is aimed at students who will go on in the major. Because of that, we set fairly high expectations: more interconnections, higher quality linking phrases, and concept maps take out about 1/3 of the quiz overall. 900, on the other hand, is a Haas elective, enrolls over 300 students per semester, has 11 TAs, and the audience is broader, with many students taking the course to fulfill a general education requirement rather than pursuing the major. We use the same rubric, but the rubric is scaled to keep grading feasible and to meet the students where they are. Students still need to be assessed on conceptual synthesis, but there are fewer required interconnections and simpler linking phrases are accepted. And the maps also account for about 1/3 of the quiz. Across the semesters, we saw very consistent, promising feedback and outcomes. First, we saw that students' concept mapping skills improved throughout the semester. Students increasingly reported that maps helped them understand and connect ideas, and the approach worked well in 2 different course contexts. We also ran into a number of challenges. The biggest early hurdles were linking phrases and interconnections. Students needed time and practice before those became natural. Our TAs and instructors also had a learning curve. The TAs in particular needed time to learn how to give clear, targeted feedback using the rubric. And then finally, the first implementation took more time. We had to set expectations, create supports, and develop the grading workflow. But once those pieces were in place, the workflow became smoother and more sustainable. Across the 7 semesters we've used concept maps, I've gathered quite a bit of advice for anyone that wants to start using them. First, scaffold the skills intentionally. Start with the basic structure and then gradually layer in expectations. Second, provide clear instructions and an explicit rubric for the grading criteria. Support your teaching team, especially if they haven't used concept maps before. There's a learning curve for all of them. Actively solicit feedback from both TAs and students. Their insights are going to show you what's working and where students may be struggling. Don't expect the first run or the second run to be perfect. Treat implementation as an iterative learning cycle. Make adjustments as you learn, even mid-semester. And then finally, have fun with it. Concept maps invite creativity, and it's genuinely enjoyable to see the different ways students organize and synthesize ideas. I want to thank a number of people. First, Mark Baer and John Gabrielli. Thank you so much for having faith in me and giving me the space to trial concept maps in your courses. Your support throughout this whole process has really meant a lot, and it allowed this project to grow. To all of our teaching assistants and teaching trainees, your feedback, support, the ideas, all of it has been invaluable, and you've been really critical in making this work. Everywhere from helping shape the instructions and the rubric to helping students and improving the feedback process. And then 901 and 900 students, thanks for giving me a chance with these concept maps, especially in the early semesters when I very much was figuring it out in real time. I want to thank Erin and Jovi for first giving me a platform to share this work back in 2022, and then recognizing its potential and partnering with me to move it toward a manuscript that's now in progress. A huge thank you to Faye, our data scientist, for extracting over 5,500 TA comments. And then thank you to Sierra for encouraging me to jump in with both feet when I'm passionate about something and for always believing in me. And then finally, I want to thank everyone here for listening. And if you're thinking about using concept maps, please feel free to reach out. I'm happy to chat.
All right. Well, thank you so much for including me today. I am going to switch us over to the math department and talk about active learning and formative self-assessment using MITx as a tool. And I'm going to speak to this mostly through the example of 1805, but toward the end, I'll talk about other places we're expanding the influence. Just very briefly, who am I? I'm someone who spent a lot of time rounding the bases at Maine and Ames. So I was a postdoc here, then a scientist at the Broad Institute, then working in biotech and drug discovery and tech at places like Flagship and Google. And now I've been at the math department a few years as the senior lecturer. And the course that I teach in the spring in the math department is 1805, which is the Introduction to Probability and Statistics. So just some history. This course has existed a long time, and in 2011, it was in need of some care. It had been handed off semester or year after year for a while. The class size had gotten quite small. The ratings were a bit poor. The curriculum at the time covered basic probability and frequentist statistics. It had traditional summative assessment, like midterms and a final, no coding, few applications. It was based off a textbook in the last few years. It also didn't cover an area of statistics that's called Bayesian, which is central to modern practice. And the thing that was maybe most troubling in terms of the feedback was that students saw very little connection between the two units, the probability unit, which is sort of the math, and the statistics unit, which is a bit of the art that in principle you should understand deeply in terms of the probability, but students had trouble making that connection. So in 2012, when I was a postdoc, I worked with Jeremy Orloff to update the class, and we ended up changing everything. So we flipped the course to make it active learning using the teal space that physics first developed for 801 and 802. Before class, students answer questions on targeted reading that we wrote. So we have a textbook essentially that's about 300 pages that we wrote and updated over time. And that's the first place we use MITx, which is for the students to be able to answer a few questions online on MITx about the reading before class as a way to incentivize that they actually do the reading. These questions aren't meant to be super challenging. They're meant to, again, make sure they opened it and they read it to the level that they can answer basic questions. And that's going to prepare them to be more engaged in the active learning classroom. So during class, there's minimal lecture. Students are engaging largely in problem solving at the board. There are a lot of TAs going around and supporting, as well as myself. We also, in the past, have used MITx to do live concept questions during class, which I'll show you. And then, of course, there's a lot of discussion. And maybe I'll show you just a video of what this looks like, because it's better than words. So this will be about 30 seconds, and I want you to pay attention to all the different kinds of interactions you see, keeping in mind there are groups of students working together, but also staff going around and helping. All right, so here's the video. This is one swoop. What is 3/5 minus 9 plus 27/48? I don't know why it stopped there. What is 3/5 minus 9 plus 27/48? Okay, so what you saw was just one look around the classroom while they were engaged on working on a board problem, which was projected. And you saw students interacting in groups of three, also helping each other, also staff interacting with them. Also, I go around and get awareness of what they're doing in order to address what wasn't understood and to not bore them with what was. Just even physically standing at these boards gets the students energized and makes the work visible and shareable for formative assessment. So this is not advanced technology. This is just, having space to stand up, move around, and write, which I think is also great. And what we do is try to position the students as learners who are becoming gradually more adept at the material and create excitement about successfully solving problems together. So comparison to lecture courses, students will say, they sit through a magical lecture, they feel like they understand it, then they get to the problem set and they freak out. Here, they freak out in the classroom because they realize they didn't understand it, but they're in a place where they have active support from staff. And again, the MITx questions ahead of time really do help them be prepared when they get to the classroom. They also worry about not losing face with their group mates who, they're working with. And so this gives a lot of formative assessment during the problem-solving process. Also, we can assess their learning as the staff and give immediate feedback. So yeah, that's the active learning component. Now, on Fridays, we do simulation, modeling, and visualization using R as a programming language. And that does not involve MITx. That just involves them using R. But the place that I want to focus on most where we use MITx is on developing these problem set checkers. So this is something Jerry and I introduced at the beginning of redeveloping the course. And I'll show you what this is in a second. Let me say one thing about how it's going. So in 2024, I had 95 students. The ratings were 6.2 for the class, 6.9 for teaching. In 2025, that grew to 123. The ratings went up. I got worse as a teacher. So anyway, there's where we're at. I expect we'll have about 150 next year, or this year, this spring, I hope. That is if they actually give us the teal space, because at the moment, physics is expanding. There's a bit of a lot of active learning space on campus, which is something else I'd like everyone to advocate for. Okay, so for those who are more interested in, what this course is about, I'll just very briefly tell you, and then I'll move on to the more assessment component. But really, this is a course to teach students the skills and concepts to navigate a data-driven world. So they learn core concepts of probability, of statistical inference. They build a starter toolkit. They use simulation and software. They should learn how to consume statistical research and papers and journalism, appreciate real-world challenges, and prepare for future job stuff. I will say that having worked in the real world for 8 years and coming back, it became much more important to me to think about these kinds of framings of what we're teaching, as opposed to this kind, which is like, here are the chapters of the textbook. Those are interesting too, but these are in service of those larger goals. And in terms of applications, they see everything from privacy in the census to climate science to literacy, reading papers, which is something that every MIT student is going to need. This last year, I spent a lot of time on climate-related science through a grant. And so we had really fun applications, like looking at correlation of temperature between Boston and everywhere else in the world, right, through the years. And you see that the Northern Hemisphere is more correlated with Boston in terms of monthly temperature averages. The Southern Hemisphere is anti-correlated. They dig into climate change and attribution of causes, so they can go home to Thanksgiving and argue with their uncle. It's a whole thing, all right? So this is the content. And now I want to focus on the rest of this talk with the use of technology. All right, so I view technology very much as a double-edged sword. It enables a lot of wonderful things for the course. I also think there are places where it gets in the way, and I've called back as a result. And I think AI is a whole nother discussion, which I'll touch on. Okay, so the course itself is based out of Canvas. So this is the homepage. It's very flat. Everything is accessible in one click. Every week, there's stuff in yellow that they do ahead of time at home, including these reading questions. There's stuff that happens in the classroom, including the slide decks. And then there's the problems and answers that we pull out of those slide decks so the students aren't freaked out about writing everything down in real time. There's also these Friday studios. There might be tutorials for that. There's the solutions, and there are problem sets, checkers, and solutions. So this is basically the entire semester as one page where everything is accessible in one click. I very much do not like using modules and week-by-week things with drop-down menus that you have to click 17 times into. That's a personal preference, but I think the students appreciate this kind of flat design as well. Okay, so I mentioned reading questions. This is what they look like in MITx. So the student will open this up, answer these questions ahead of class, or they don't get credit. It's 5% of their grade. I also mentioned concept questions. Those look like this. They have answers, which could usually multiple choice. And the nice thing about doing these in class, is you can see live results and you can project them in terms of bar graphs of where the students are. So when you see controversy, you get them to discuss it, you get them to update their answer, and that can be quite fun. What I found, though, over time is that I'm less inclined to use MITx for this purpose, simply because students are opening up their phones or computers or tablets in class, and before you know it, they have trouble putting them away. And so I instead have moved back to having them use their fingers and having a blanket rule, no laptops on the desk. And I actually think it helps with engagement because they're in front of their screen so much, it's just hard once they're open to put them back. And then there's the problem set checkers. All right, and I'm going to go into more detail on this in a moment, but just to see visually what it looks like, for every problem on the problem set, there is a little box. You can type a number or a formula or a matrix or a vector or whatever. You hit submit. If it's right, you'll get a green check. If it's wrong, you'll get an X. You can try up to 100 times. You are not graded on this at all. It is totally optional. But you can use it ahead of turning in your problem set to know if you've gotten things correct and move on, or whether you need to go seek additional help. Okay, so this is the basic idea of the checker It does not tell them the right answer. It just allows them to verify that a final answer they got was correct. And they're only graded on the full solutions they submit to Gradescope. They're not graded on this at all. Okay. So that's how I'm using technology to support the course. Now, I mentioned, so Gradescope, that's where they submit their solutions. Piazza is a discussion forum where we can talk about things like current events related to the class. We spent a lot of time talking about vaccine science last spring, as you can imagine. I'm sure we'll be doing that even more based on all the articles coming out this term. The use R in our studio. One thing I do want to emphasize, AI has not completely changed everything. In fact, it's changed very little for how I envision what works in this course. And the reason is, I think the way that AI is helpful to education has to be contextualized as to whether we're talking about distance learning, making things more affordable, more interactive, cheap at a distance, versus residential education, where we bring people into a physical space and we can embody their learning. And I feel strongly that the best use of the time students have together is to interact with each other and with the staff. And for this reason, I think once we had VCRs and video cameras, we should have stopped lecturing for most math classes, frankly. But it's a slow process. There isn't a lot of that space here, so we'll do what we can. And what has AI changed? Well, I don't care anymore about updating the problem sets just to make them different so the students can't cheat, because they can cheat. Like, there's no question. They could do it before and I could pretend they weren't cheating, but now it's like so easy that what I worry about instead is them going ahead to cheat because they're just worried that they'll lose some points if they don't get it right. And then they rob themselves of the experience of actually suffering and learning. And so I don't worry about updating great problems every year anymore. And that's wonderful. That's a huge positive benefit of AI for me. They're going to cheat if they want to cheat. I can't stop it. Now, on the other hand, I increase the weight of exams relative to problem sets. The problem sets become more incentivized as preparation for the exams, which count for most of their grade. They can't cheat on the exams as easily. And I think it increases the value of these things I've called problem set checkers. Okay, so the rest of this talk, I want to dig into that. And I think I have a few minutes. Great. So this is the last slide. What are these problem set checkers? So I showed you they're just checkers on MITx where you can enter numbers or functions or other things into boxes and see if they're right. Now, not every problem on a problem set will have a final answer like that, but the vast majority in a math class do. And so it enables students to verify the correctness of final numeric or symbolic answers so that they can detect, reflect, and correct mistakes while they still care before they've turned it in, as opposed to what we observed when we first started teaching this course again. It didn't use this, which was we would turn back problem sets that were graded. They were on paper at the time, and half the students wouldn't even pick them up. And I'm sure even among the students who picked them up, very few had time to go back because they were now distracted with other things. So here, the students are incentivized because they still get points or don't get points, whether they get it right when they turn into Gradescope. And they know if they try and they can't get it, they should talk to their classmates or go to office hours, which is even better for the embodied component. Again, they do not reveal the answers, but they do allow you to create more challenging problems on the problem sets by scaffolding them into parts A, B, C, D, so that the students can at least have some verification along the way that they're on the right track. So they don't get totally frustrated and off track because the beginning, was already wrong and then everything else was hopeless. Again, they're optional, but pretty much every student uses them. The way this helps the graders is that they no longer are the answer checker. They don't experience students coming to them and saying, like, did I do this right? Because the students can check that themselves. It's kind of a waste of a grader's time to serve that function. And so the graders can focus more on substantive misunderstandings. And this is also when they're grading. When they're grading, 99% of the things are correct because the students have the chance to check them and they can go grade more efficiently. And when there are issues, they're more about the reasoning and the graders can focus on that, which is a better use of their brains. The students who are worried about losing points, like the ones who want to go to med school, have a strong incentive to use AI to cheat because they don't want to lose the points, even if they think they probably got it right. But by giving them this opportunity to sort of pseudo cheat, maybe they're going to be a little less inclined to go for those opportunities. Now, this is something I use in 1805 and in all the other math classes I teach, including in the experimental study group. But I was excited to think about how we could scale this. So in summer 2025, we applied for a Canvas Innovation Fund grant with the Office of Open Learning. And one of my students and advisees, María Ortiz Benítez, worked with me and Meredith Davies at Open Learning to create checkers for mainstream math classes, 1806, and the ESG class 1801, as well as documentation on this whole process so other people can try to do it too. And then this fall, she created checkers in real time for 1802, which is also a huge class. And That's gotten extremely positive feedback from the professor, John Bush, and the course staff, and they're surely going to use them in the future as well. So that's exciting because now we're influencing, 1,000 students, let's say, instead of like 100. Let me show you the documentation very quickly. So this is a PDF that Maria created. It's currently 19 pages, but it basically takes you through the whole process she uses to create different kinds of graders for numbers and formulas and strings and matrices and intervals and so on. And so it's a starting point for others who are interested to do this, but of course you can talk to us directly as well. And if there's 1 minute left, I actually want to give Maria herself an opportunity to say a word about her experience on this project. So I'm going to stop sharing, and maybe she can be pinned and pop on the screen.
As John said, I worked with this problem checkers. I didn't know how to build any of this. I only had the other perspective, the student perspective on the problem checkers. So during summer, with really basic Python knowledge and LaTeX knowledge, I was able to go through documentation and learn how to build up these checkers. I created some checkers for 1801 and 1806 during summer, so I already had the templates for different kinds of problems. And this made it really easy to build the checkers in real time during the semester for 1802, because one of the issues that we had was that they were creating the Psets while the semester was going on, so I couldn't build them during summer. But since I had the templates that I built for other classes during summer, it was really easy. It didn't take me more than 3 hours to build each checker. So yes, it was a really easy job. As John said, we got really positive feedback by the end of the semester. It was funny because at the start, the staff was a little bit uncertain about whether the checkers would be useful or not. But John and I both saw a change in their perspective during the semester, and by the end of it, I think we are pretty sure that the checkers were useful for students, and we're really happy with that.
Thank you, Maria. So the last thing I'll say is, we can look at the data after the semester ends and actually see utilization by digging into MITx's logs. But if anything is similar to the courses I do, it'll probably be almost fully utilized. And I noticed there's a question here about why can't they cheat on exams? It's because they only have pencil, paper, and no technology on exams. So that makes it harder. And the last thing I'll say is, I think there's opportunities to do this, not just in math classes, which is my focus at the moment. I think physics already does do this to some extent, to the extent they put things in MITx for their TEAL courses. But if people want to think about this in other departments, please do reach out, and happy to chat. Thank you so much.
All right. Thank you, Jovi, and thank you for inviting me to talk and for taking time out of this very busy time in the semester. So I'm going to talk a little bit about oral communication skills. I'm the director of RAP, the program in Writing, Rhetoric, and Professional Communication. And obviously, one of the things that we're very interested in is supporting students in their communication requirement, which includes written, oral, visual communication skills. And as you can see here, I put a picture of a talk that I did in the summer in front of an audience that I had no idea how to address. They were Olympic educators. It was in the International Olympic Academy. And it's always a real issue. How do we improve? How do we get feedback on our communication skills? So I teach a class called Writing About Sports. It's a first year class, although sometimes second year or even seniors sometimes want to go into improving their communication skills through sports. And if you look at the learning outcomes for CHW subjects, the first one obviously is create and shaping texts, not only written, but also oral texts for different purposes, audience and rhetorical situations. But one of our outcomes is also understanding how to critique each other's texts through the peer review process. And it's easy to look at, to think about rhetoric and rhetorical skills in terms of the art, the technique that goes into how you learn how to communicate. But thinking about it from an ancient perspective, we know that this technique, this rhetorical art, essentially comes from two places. One is habit formation, which is, your 10,000 hours of doing the same activity and eventually getting it right. And the other is the idea of developing the disposition on your writing or your oral communication. And this disposition comes out of two places, again, according to ancient rhetorical frameworks. One is observation. So you sit down with somebody who knows what they're doing and you pay attention to what they do and you identify patterns and you figure out these patterns and say, okay, this is how I should do it. And the other is feedback. So I'm a big proponent of feedback, and we do that a lot in our CI classes as communication instructors. So one of the things that I realized very early on is that we have some really good tools to provide feedback on writing, especially uh, even in Canvas. Speed Grader is one of those tools. Here's an assignment from this semester's class, and you can see I've redacted in black the names of the students, but you can see that we have very complex ways to provide localized and meaningful feedback, and I haven't even included rubrics here when it comes to writing. But we don't have the same kinds of tools to provide feedback to students when it comes to their oral communication, to their oral presentations. At first, back in 2023, I said, I want to have some way to provide real-time feedback to students through a survey instrument. So outside of Canvas, I used the Qualtrics survey, and you can see an example here where we've had some core categories all the way from invention to delivery. And the students basically dragged and dropped very quickly if they felt that the core message worked well or the structure worked well or could have been better. And then a few really quick comments on what worked or what didn't work or what their fellow students should be improving for the following exercise. I have to say that in a lot of these classes, I try to have students give multiple oral presentations, mainly because I feel that, having high stakes oral final presentation types of things doesn't give them enough of an opportunity to be able to build on these communication skills. Now, this model with a Qualtrics survey was quite useful, but it had a significant overhead cost because I would go back into Qualtrics, capture what the results were for each student. Here it's graphical results. You can see the student did quite well on the overall structure, but then a lot of the fellow students said the level of detail or complexity could have been better. Whereas for another student, again, overall structure was positive, but you can see more categories were positive. And in most cases, yes, students to one another, they want to say positive things first. But the cost was I had to go to Qualtrics, take screenshots of all these things, and start emailing students with both the graphs, those bar graphs, and also the written comments that they receive. Beyond that overhead cost, as you can see here, the comments by their fellow students were quite general, addressed the talk overall. So what worked well? Your slides were simple yet effective. All of the slides, half of the slides, it's a very general comment, whereas in writing, we're able to localize and say, okay, here in this paragraph, this is what's happening, this is what it seems that you're doing, this is how it could be improved. Whereas with this model, they could only make a very general comment about the whole presentation. So in the summer of 2025, I was very fortunate to be able to work with Nicholas Stone Perez, who's now an MEng student and was in the writing about sports class when we first started some of the more oral communication, and I'll tell you the visualization assignment, and with Aaron Kessler from ODL. And basically, I wanted to explore how we could use some of the existing Canvas tools to create a peer feedback mechanism for oral presentations. which I felt we needed. And as you can see, they're both smiling here. That's before the project. I don't know what happened after the project. I think it went really well over the summer. They were wonderful to work with. So part of what I try to teach students in this class is how to build from data uh, communications that focus on a visual related to sports, but they also present to their fellow students. So to do that, I try to scaffold it through three different kinds of presentations that they give. First, they give a presentation analyzing a visual rhetorically. It takes 4 to 5 minutes, but essentially they talk about visual design principles, what the audience of the visual is, the context, what the persuasive strategy is. And that's a visual that they essentially take from anywhere. If you look at, any sports related website, it's full of data-based visualizations right and left. Then they start creating their own visuals, which is a 4 to 5 minute presentation on some kind of historical data. Sometimes we work with data from the NBA. Sometimes we work with data from soccer, but it doesn't matter what the sport is. It's really how to look at this data and say, how can we explain something, usually a question of causation or quality? Why did a team win this tournament? Or if the assisted referee system in soccer is fair or something, and to craft a visual story that explains this sports related outcome. The most important and most interesting piece for them, however, is the third part, where now they start building visualizations to predict what will happen at a specific tournament. And we started that for the 2022 World Cup, which happened to be during the semester, the fall semester, which was great. And we kept doing it for, if it's a spring, 2025, let's say spring, the NBA playoffs, and so on. So not only do they have to come up with a visual representation of the data and talk about their analysis, but they also have to persuade their fellow students that their explanation is probably going to come true. It predicts reality very well, in contrast to another student. So I have two students present on the same type of question. So essentially, they have to integrate skills in data analysis, visual storytelling, and audience persuasion. A few years ago, there was a video about this class, and one of the things that I said that is really very important for me is they have to learn how to tell the story of the data. And on the right-hand side here, you see a visual that I show them from one of the textbooks on data storytelling. You have data that's kind of all over the place. You can sort it, you can arrange it, you can present it visually, but once you explain it with a story, that's when you actually have something that your audience can relate to and recognize, such as a house here. Now, when I started working with Nicholas and Aaron, we realized that we have an affordance, and the classroom where I teach is a Zoom-enabled classroom, which means it has the cameras, and very easily it allows us to either bring people in from Zoom. Actually, this is a screenshot from a couple of weeks ago, the Tuesday before Thanksgiving. A couple of students had already left to go home, but they were able to Zoom in so that they could deliver their presentations. But it also allows me to record things very quickly and have them be sent to my email directly. Which means that then I can take them and put them on Panopto. So the solution was, let's take these videos from students presenting, put them on Panopto, and then once you upload it, you can very easily go to the discussion area of Panopto. And as you can see here, students can start adding comments that are specific to, there's a timestamp 1602, 1621, and they're very specific, as you can see here, to, what the student is doing, what their fellow student is doing in terms of persuading that this is going to happen. Now, for those of you who know soccer, the student said that Liverpool was going to beat PSV Eindhoven 2-1. That didn't happen, but it doesn't matter. What mattered was their argument convincing for their audience. So let me show you now a couple of actual quotes from students based on a mini reflective quiz that I did with them after they complete this whole process. I wanted to ask them a few questions about the whole process of receiving feedback and also what it means for their own understanding of how to generate these presentations. So based on the feedback you received, what would you have done differently in your analysis? First student said, well, I had the data, but it lacked the storyline. So the second time around, she actually added a storyline. Another student said, well, persuading an audience is much like a performance. Delivery plays a crucial role, but tone, body language, storytelling, it's harder to truly persuade. Data doesn't speak for itself. I can go blue in the face telling data doesn't speak for itself in lecture mode, but once they see it in the feedback that they give and receive, it, I think, sticks. Uh, Based on the feedback you submitted to your fellow students, what did you want them to pay attention to? This? Another student says, building a story. Give your argument an emotional presence. Okay. What did you learn overall about presenting by this process of giving feedback on your colleagues' presentations and also receiving feedback? The student said, I noticed things in the presentation of my partner, and I wanted to be able to think about how to include them in any of my future presentations. So it's not just about giving feedback to someone, to help them, but it's also helping the person who is the reviewer to then consider how they could take some of these patterns or strategies on for their own presentations. And the last one, what did you learn overall about presenting by this process of giving feedback on your colleagues' presentations and receiving feedback? The student said it made the whole process of learning much faster and clearer. So what I'm trying to say is that this simple, in many ways, adjustment to the way that we give feedback by recording and then putting everything on Panopto and giving them the space to give feedback made sense to them, because for me, it essentially reinforced the main idea of data storytelling, but for them, it felt that it was faster and clearer to get this process of learning done. However, was it all because of the feedback process? One of the students actually pointed to the idea of observation. I learned from just watching others present. I noticed there was a pattern. The presentations included a bit of storytelling, so I wanted to do the same thing. Like I said, observation and feedback both work well. And we also had a student who took a more sophisticated approach to learning and persuasion and basically said, you don't have to be an expert in the area you're talking about to build a persuasive argument. Just make the audience trust you more, which kind of goes against the whole MIT idea of putting a lot of our emphasis on really good data and analyzing the data in ways that are robust. But, there's something to be said about moving an audience in certain directions, even though the data might not entirely support it. We can talk more about that. So the vision for the future. Years ago, that's a screenshot from a class like 10, 12 years ago. I was trying to figure out a way to have this be a real-time tool, which I called Metalogon, but it never went anywhere because it was, a whole different thing that students would have to do. But basically take the idea of have some core categories, have the students be able to go back to the presentation, watch their fellow students presenting, and then make comments that are time-stamped, then that give them both a description of what they see their fellow students doing and some kind of effectiveness rating. But for now, the Panopto version is really going to take us to the next step, and we'll see how we can improve upon that. thank you very much. If you have any questions or you want to talk about this model, please let me know. Here's my email.
Just like a couple of quick comments, I think, around all three of your presentations. I think what's really interesting is that all of you kind of, in different contexts, are doing things in ways that are helping students to see that the progress, like over time, matters. It's not just like you do one kind of exam or one kind of problem or one kind of thing and it's done. It's actually like building that out over time, and ensuring they're getting some kind of targeted feedback, right? Whether it's like the types of categories Laura has developed with her concept map feedback, or the kinds of problem solving, and where there's misunderstandings perhaps in concepts, in John with the math course and Andreas with like time-stamped exact areas of like what parts of the presentation perhaps need work and which parts are great. So just wanted to say thank you all for putting the work into kind of make those experiences happen for students. I'm sure sometimes for students it's not always easy. Like students sometimes want to just show that they got things done right the first time around, or that are used to maybe doing that. And I'm curious if I know we don't have too much time. If you have any advice or tips on helping students sort of get past that. Is it just the whole experience of the course that you think maybe gets them there in all your cases? Or do you think there's something specific that's good to know? Whoever wants to jump in on that can. I will probably have time for only maybe one more question after that. And just a quick heads up, if anyone here has questions and you feel like we're out of time, you can always email my team at ol-residential@MIT, and we're happy to respond to you there also.
I think for the concept maps, one thing we noticed in terms of students learning the skill, even though it was a big adjustment compared to what we were doing previously, is having a lot of opportunities to have them ask questions. So like in recitation, also asking for their feedback and then discussing the feedback with them, I think is really critical and makes them feel like they're more involved in the decision-making process. And one thing I do want to note is every semester I have at least one student write in the feedback that something that helped their learning was, I hate to say it, but concept maps really helped. So, they're hesitant, but they are willing to put in the work, especially if they're given the right supports.
Yeah, I'll add to that. I think on the bigger scope of active learning, I have tons of students in the first week who are like, wait, I actually have to show up to class. I actually have to participate in class. And then a number of comments by the end that they wish more of their classes were taught this way. And I think part of it relates to the question of how do you get students sort of up this ladder of understanding. I think driving them to interact and ask questions of each other and the staff is an important way. I think the checkers help enable that by helping students identify for themselves what they don't yet understand. Also the active learning in the classroom, also the reading questions. Also, maybe I'll add with Piazza as well. One thing we do not do is use Piazza for problem sets. We do not allow students to ask for hints or ask questions about the P-sets on Piazza because we think that incentivizes them waiting until the last moment until there are hints, or disincentivizes them from coming to office hours, which we have a ton of. So, the ways in which we use this technology, I think, matter a lot for helping students engage and feel motivated and be willing to suffer a bit, because if they're not struggling, they're probably not learning anything new.
On my end, let me just say that, and we can talk a lot about oral communication, but I'm very interested in seeing dialogue develop in the class in multiple ways, and not seeing these oral communication assignments as, only ways for them to get a grade, but also ways to engage in dialogue with their fellow students as audience, but also as people who support them in their, quest to become better communicators. I think that helps a lot.
Yeah, there's something there with the learning from each other piece. I think that I kind of heard from each of you that I think really, really ultimately helps the students also, right? Whether it's like seeing examples from your peers or seeing how they are approaching a problem or seeing how they are doing a presentation. Those are all really unique opportunities for students to learn from each other and hopefully, build a sense of like learning together. Anyway, all that being said, I know it is a very busy time of the semester, so I think we will bring this talk to an end for today, and just want to say thank you to Andreas, Laura, and John for your time in preparing and being here with us today, and thank you to everyone for being here to hear from them. And enjoy the rest of the term. I know it's busy, but hope you'll make the best of it. Wishing you all the best of luck and see you next time. Bye.